Good morning, students. I'm Visweswara Rao. Good morning, students. I'm Visweswara Rao, sir. Today I'm continuing NCERT problem solving series. This is class number 2. In the previous class, I discussed how to find the hybridization. In this class, finding number of sigma bonds and pi bonds. And these are the examples given in the NCERT textbook. First, I take up benzene. Last class, I ended the class with benzene. Now I am starting the class with benzene. I already told you how to identify the hybridization of the benzene. So once again, I am writing the benzene structure, one of the Kekulé structure. So this is the benzene's Kekulé structure. C double bond here, hydrogen, hydrogen. So you can count the number of sigma bonds and pi bonds here. It is a double bond means one sigma bond, and this is one pi bond. Here also it is simply sigma bond. Here one sigma bond, one pi bond. Here only one sigma bond, one sigma bond, one pi bond. Here only one sigma bond. Like that you can count. Here also CH sigma bond, 6 sigma bonds are there. So very simple information. This is very simple information. Altogether, how many CC sigma bonds are there? 6 CC sigma bonds are there. 6 CH sigma bonds are there. So total number of sigma bonds is nothing but 12 sigma bonds. How many pi bonds are there in the benzene ring? 3 pi bonds are there. So generally, if a paper setter converts this information given in the NCERT as a question, he may give that Visweswara Rao, what is the ratio of the sigma bonds and pi bonds in the benzene ring? Like that, you can frame a question. That means the ratio of the sigma bonds and pi bonds. Ratio of the sigma bonds and pi bonds means that is simply 12:3. 12:3 means you can easily do this one. And this is 4 times, that is 4:1. So sigma bond pi bond ratio is 4:1 or pi bond sigma bond ratio is 1:4. Like that they can ask. They can also ask you one question. What is the ratio of the sp2 hybrid orbitals and atomic orbitals in the benzene? That is also very popular among the paper sectors. sp2 hybrid orbitals means all the carbons are sp2 hybrids. 6 carbons are there. sp2 hybridization means 1 s orbital, 2 p orbitals. Total 3 atomic orbitals participate in hybridization. That means 3 atomic orbitals are participating means you will get 3 hybrid orbitals. So 6 carbons having everybody is undergoing sp2 hybridization. Everybody is having 3 hybrid orbitals now. So 6 carbons means 6 times 3. That is 18 hybrid orbitals. So benzene is having 18 HOs, 18 hybrid orbitals are there. How many atomic orbitals are there? How many atomic orbitals means carbon is having 4 atomic orbitals in the outer post. That is 2s, 2px, 2py, 2pz. In sp2 hybridization, one 2s orbital, 2p orbitals come into hybridization. Each carbon is left with one 2p atomic orbital for pi bonding. So 6 carbons means 6 atomic orbitals are there. On each carbon, one 2p orbital, 6 atomic orbitals are there. But not only that, 6 hydrogens also there. So each hydrogen is nothing but s orbital. So 6 s orbitals, 6 p atomic orbitals are 6 carbons, 6 s orbitals and 6 hydrogens, total 12 AOs. AOs means atomic orbitals are there. So the ratio of the hybrid orbitals, atomic orbitals, is, you can divide with the maximum possible number. That means 6 times 2, 6 times 3. So hybrid orbitals is to atomic orbitals in benzene is nothing but 3:2. Like that also they can ask now. And one more thing, out of the 12 sigma bond, 6 sigma bonds are sp2 overlapping. 6 sigma bonds are formed sp2 overlapping. So this carbon-carbon sigma bond friend that is formed by sp2 overlapping. Okay. This fellow, that means carbon hydrogen sigma bond friend that is formed by sp2 hybrid orbital of carbon and s orbital of hydrogen. Like that also they can ask you question. This pi bond is nothing but p pi bond. So what is the meaning of p pi bond? P atomic orbitals overlap sidewaysly. Then you can say that is nothing but p pi bonding. So this is generally they will ask the questions like this. Nana. I don't think any student face difficulty in counting the number of sigma bonds and pi bonds. Of course, I am coming to the next example, and this is the next example C6H12. And sometimes that means in this case, I given complete formulas because the formulas are given in the NCERT textbooks. Sometimes paper setters will give names also, not hexane. Especially this compound, what I am taking is nothing but cyclohexane. Practicing the IUPAC names is very important for any kind of examination. So sometimes paper setters ask you IUPAC names instead of giving the structures. Why? What is the reason? Most of the examinations, if you draw the structures, they may be printing errors will be there. That's why most of the paper setters are likely to give IUPAC names or trivial names. Ethyl chloride is easy to write. So writing this formula in the question paper is a little bit difficult for typesetting. And writing ethyl chloride is simple English writing, it's easy. Or paper setter may simply give chloroethane. Because of that convenience, most of the times paper setter uses these names now. So be careful with that. You are writing the competitive examination, especially. They must have a clear-cut understanding of the IUPAC nomenclature. In this series, I will also discuss all the NCERT questions of the IUPAC nomenclature. So anyway, come to the present example, counting the number of sigma and pi bonds and also hybridization. In the previous class, I told you. And this one generally written like this one, line structure. This is called a bond line structure. So every junction is having carbon. So this carbon is there, carbon is there, carbon, carbon, carbon. And this carbon, I'm only showing the 2 bonds for the carbon, 2 more bonds are there with hydrogens. Like that. So here also same thing, 2 bonds are explicitly shown here, but 2 hydrogens are connected here. Here also 2 bonds are shown and 2 hydrogens are connected here. Here also like that. So I will do one thing. I will write the full-page structure for you. Okay. It is only to understanding purpose, Nana. Anyway, it's very simple. It's not at all difficult. But you have to practice the line structures also. And once again, the same reasons. Giving the line structures is more easy to the paper setter compared to given this kind of the big structures. So usually, if you see the previous NEET question papers, mains question papers, and usually these kind of structures you see in the questions now. That is the reason, convenience of paper setting. Now, you can easily count this one, that means 6 sigma bonds are there, CC sigma bonds are 6 are there. So 6 CC sigma bonds are there. And each carbon is having CH sigma bond. That means each carbon is having 2 CH sigma bonds now. So that is nothing but 6 into 2. 12 CH sigma bonds are there. No pi bond. Total number of sigma bonds is nothing but 18 sigma bonds. And one more thing. What is the hybridization of carbon? Carbon is forming 4 sigma bonds, no pi bonds, friends. sp3 is the hybridization. All the 6 carbons are sp3 hybridized carbon. All the 6 carbons are sp3 hybridized. And one more thing, all these 6 sigma bonds, CC sigma bonds, and formed by overlapping of sp3 HOs, sp3 hybrid orbitals. This CH sigma bond, friends, sp3 hybrid orbital of carbon S orbital of hydrogen getting overlapped. So that kind of questions also you may get none. So like this, so if I solve any number of examples, you will have this kind only. So that means I will leave some examples for your practice also. So for example, I'm going for the next one. So this is the given in the NCERT textbook. It's simply asking, you simply have to count how many sigma bonds are there, how many pi bonds are there. There is no straight formulas to do that one, Nana. So straight away you write the structure properly, you just count that. Okay. So that is the best thing. So this is nothing but I'm writing the, so this is the CH, triple bond, carbon, and C. Here hydrogen is there, double bond, carbon. Here hydrogen is there. And I'm writing completely here like this for your understanding. Once you practice this properly, no need to write like this. You can directly count the 3 CH sigma bonds are there. So I written the structure clearly for your understanding only here. Now you see, I'll go for this one. This is the sigma bond here. Sigma bond, sigma bond, sigma bond, sigma bond, sigma bond. What I counted so far? 1, 2, 3, 4, 5, 6 now. So 6 CH sigma bonds are present here. That's what I counted. Okay. I counted them separately because paper setter may ask ratios like that. And among this one, these especially these are formed by 3 CH sigma bonds are formed by sp3 s orbital overlapping. So the hybridization of this carbon fellow is sp3, right? And the hybridization of this carbon is nothing but sp2. That means that this is formed by, this is also sp2. So out of these two sigma bonds, CH sigma bonds are formed by overlapping of sp2 and s hybrid orbital, sp2 hybrid orbital and s orbital. And this is sp hybridized. So one sigma bond, one CH sigma bond is formed by overlapping of sp and s hybrid orbital. Like that, even though these are very simple, repeatedly you are getting questions, easy questions. You can easily answer these questions. Okay. So anyway, I counted total number of sigma bonds, CH sigma bonds. Okay. I clearly explained what kind of hybrid orbitals and atomic orbitals involved in those things. Now, here you are having two pi bonds here. Here you are having one pi bond. So 3 pi bonds you are having here. 3 pi bonds, and the last one is carbon-carbon sigma bond. Here one carbon-carbon sigma bond. You can see carbon-carbon sigma bond is there, formed by sp-sp overlap. Here another carbon-carbon sigma bond you see formed by sp and sp2H now. This is sp hybrid orbital. This is nothing but sp2 hybrid orbital. So this sigma bond is formed by sp hybrid orbital of this carbon and sp2 hybrid orbital of this carbon. And here another carbon-carbon sigma bond you can see that is formed by sp2 hybrid orbitals overlapping now. Okay. So under structures, if you know these structures quite well, you can understand the subject easily. So this is the most fundamentals. You have to understand most fundamentals, first of all. So anyway, I finished that. And what about this one here? This one is nothing but I just cut this one, right? For clarity, I'm simplifying that. That is also carbon-carbon sigma bond. But if anybody asks you what hybrid orbitals involved in the formation of this carbon-carbon sigma bond, you can say sp2 and sp3. sp2, sp3, HOs. Total, that means 1, 2, 3, 4. 4 carbon-carbon sigma bonds are there. So 4 carbon-carbon sigma bonds, 6 carbon hydrogen sigma bonds. So total number of sigma bonds is nothing but 10. Total number of pi bonds already counted, that is pi. Carbon is only having p atomic orbitals. All the pi bonds in the almost in carbon-carbon pi bonds, p-pi bonds only. That means p orbitals are involved now. So like this, you can finish the solving problem now. I think you can easily solve this question. Yesterday also, I told you one very important precaution. That means in the last class also. Anyway, I will do it again, only for your confidence, only for okay, Nada. So I will do it again. So this time, what I'm going to do, I will write clearly, Nana, that because some students, maybe kids, straight away just now started learning organic chemistry. So that's why for them also, it's for all. Okay. So anyway, what is that? This is sigma bond, sigma bond, sigma bond, sigma bond, sigma bond, sigma bond. So CH sigma bonds 1, 2, 3, 4, 5, 6 now. So 6 CH sigma bonds. I told you how to identify hybridization and everything. I'm not I'm not mentioning that one. It is sp3. It is nothing but sp2, and this is sp2. What about this fellow? Critical. So that means in the last class I told you the important precaution. Now also I'm telling that one. So carbon forming double bond, sp2 hybridization. Carbon forming single bond, sp3 hybridization. Carbon forming triple bond. So if carbon is forming all the sigma bonds, single bonds, sp3, that's correct. Carbon forming double bond, sp2. This is also forming double bond, sp2. But if you learn like that, carbon forming double bond, sp2, you see this fellow and immediately recognize it is sp2. That is not correct. That is wrong. Don't learn like that. In the last class also I told the same thing. Carbon forming no pi bonds. No pi bonds sp3. 1 pi bond sp2. 2 pi bonds sp. That is the correct way. So this carbon fellow forming 2 pi bonds. That means this is sp hybridized carbon. So this carbon is sp2 forming 1 pi bond. It is sp2 forming 1 pi bond. No pi bonds sp3. So you can now easily, and that means what about this one? Carbon-carbon sigma bond, carbon-carbon sigma bond, sp2 sp overlapping. Carbon-carbon sigma bond, sp2 sp overlapping, carbon-carbon sigma bond. Here also you can see carbon-carbon sigma bond, but sp2 sp3 HOs are overlapping. So I got 4 carbon, 3 sigma bonds. So 3 carbon-carbon sigma bonds, total 9 sigma bonds you got. How many pi bonds? You can clearly easily see that one. Here 1 pi bond you are seeing here. So this is 1 pi bond. This is another pi bond and 2 pi bonds. So this is the thing now. 9 sigma bonds and 2 pi bonds. Like that, you can count the sigma bonds and pi bonds. They can also ask ratios like earlier I told you. Okay, everything. That means next, I don't think you need this one, Nana. I think this fellow also you can easily solve. So anyway, I'm taking this example. That example, we'll see what happens there. I will paste here that example. Okay, this is the example. So don't worry by seeing this HCONHCH3 like that. So that is nothing but C double bond O H, and this is amide functional group. Nitrogen, I will write the hydrogen bond separately. Carbon is connected here. Okay, so carbon is connected. So carbon is connected with the 3 hydrogens. I clearly written. So why paper setters are giving this kind of things now? It's easy to type. Okay, even I don't think they may also give the names also. Okay, I will come to the naming thing in the IUPAC nomenclature. Now you see what you say now in this case. In this case, it is a sigma bond, CH sigma bond, CN sigma bond, NC sigma bond, and these are the CH sigma bonds now. Okay, hybridization. Hybridization means this carbon forming one pi bond, that is sp2 hybridization. This carbon fellow forming no pi bonds, sp3. What about the nitrogen? In the previous video, I definitely told you how to find this one, Nana. No need to write any electronic configuration. You can simply, that means at least for second period elements, carbon, nitrogen, oxygen, all these are second period elements. So it is forming 3 sigma bonds. You see, carbon is forming 3 sigma bonds, Nana. So I think I forgot to mention the sigma bond. This is also a sigma bond. Nitrogen, I'm sorry, it's not carbon. Nitrogen forming 3 sigma bonds. To form 3 sigma bonds, you really need 3 hybrid orbitals. To accommodate lone pair, to keep the lone pair also, you need another hybrid orbital. So this nitrogen fellow needs 4 hybrid orbitals, friends. It is undergoing sp3 hybridization. So if anybody asks you how the sigma bond is formed, sp2, sp overlapping. How the sigma bond is formed, sp3, sp3 overlapping. How the sigma bond is formed, sp3, s orbital overlapping. How the sigma bond is formed, sp3, s orbital overlapping. How the sigma bond is formed, sp2 and hydrogen, s orbital overlapping. So and also one sigma bond here, one pi bond here. Now I'm mentioning none. I almost forgot. Okay, and this one you see total number of sigma bonds. You may get doubt, sir. Every sigma bond identified. What hybrid orbitals are participated? But what about this thing? What about the sigma bond? That sigma bond, if you like hybridized very much, that means generally in organic chemistry fellows, people generally take hybridization for each and everything. Two different schools of thoughts are there. Somebody like hybridization, somebody don't like hybridization. But if you want hybridization for this oxygen also, you can do it now. You can definitely do it that same way. Same way means it is forming one sigma bond. To form one sigma bond, it needs one hybrid orbital. To accommodate lone pairs also, it needs hybrid orbitals. So this oxygen needs 3 hybrid orbitals. Oxygenating 3 hybrid orbitals means it is undergoing sp2 hybridization. sp2 hybridization. So if you want to, I don't think anybody asks you that one. If you want hybridization way, you can take the sp2 hybridization for oxygen. So obviously the sigma bond is formed by overlapping of sp2 and sp2. I think I completed, almost counted. So this one, I'm checking again. And this one, right. So 1, 2, 3, 4, 5, 6, 7, 8. I don't want to miss any sigma bonds. 8 sigma bonds I'm saying, and only one pi bond I am saying. This is how you can do the counting of the sigma bonds and the pi bonds, hybrid orbitals and the atomic orbitals, their ratios and everything done. I think I almost completed this one, and you can almost solve this one. Only 2 questions I left for your practice, CH2Cl2 and CH3NO2. You can solve all by yourself now. So this is what I'm doing is, I'm solving all the NCERT problems now in organic chemistry. This is the second video lesson. And the next class, I will take the third video lesson and I will go further now. Thank you, Nana. Thank you for listening.